Quadratic inequalities. Remember that when we're graphing inequalities in two variables, those are going to be graphed on the coordinate plane. And again, just a couple reminders. If you have a less than or greater than sign, we're going to have a dotted line. If it's a less than or equal to or greater than or equal to, it's going to be a solid line that you draw. For shading, if it's less than or equal to, you're going to shade down from the y-intercept on the graph. And then if it's greater than or equal to, we're going to shade up from the y-intercept on the graph. So first we're going to practice graphing one quadratic inequality at a time. Now in order to save some time, what we're going to do is use the calculator to get some points that we can plot for our parabola. So if you need a reminder of how to do this, make sure you watch the video that goes over graphing quadratics using the calculator. So after you plug this in, the coordinates you'll get from the table are as follows. So let's go ahead and plot those points. We have -1, 0, 0, -3, 1, -4, 2, -3, and then 3, 0. And when we go to sketch our parabola, remember, because this is either, it doesn't have that equal sign underneath it, we're going to use a dotted line to sketch our parabola. Now the last thing we need to do is shade. So remember, this is telling us that y is greater than the parabola. So remember, I told you find the y-intercept of the graph, and when we're shading all the y values that are greater, that puts us inside of the parabola. So this is where we're going to shade. Now for the second example, if you feel comfortable with this, I want you to pause and try it on your own and check back with me. But if you're not too comfortable with it, just stay with me and we'll walk through this step by step one more time. So again, first you're going to start off by taking your quadratic, ignore the symbol for a second. You can just use the y equals on the calculator. Put this equation in, and then you want to use your table to find integer coordinates. So when you do that, these are the coordinates you should get from the table on the calculator. So the first thing we want to do now is plot them on our graph. So we have 0, 4, 2, 8, and then I know it's not an integer, but I took 3, 8.5 because that's going to be the vertex. And then we have 4, 8, and 6, 4. And then after we plot that, we want to sketch our parabola. So we look at the inequality symbol. Remember, because it says or equal to, this equal to symbol down here, that means we're going to sketch a solid line. Now, the last part is our shading. So it says less than, which means that y is going to be everything smaller. So again, you find the y-intercept of the graph, and then we want all the y values that are smaller. And again, this happens to be inside our parabola, so this is where we want to shade. When we're graphing a system of quadratic inequalities, first you want to graph both inequalities on the same coordinate plane. Then identify the intersection of the shaded regions. So let's go ahead and graph this first one. I'm going to graph it in purple. So when you put the equation into the calculator and use the table, these are the coordinates you should get. So now we can go ahead and plot. So we have 0, 0, 1, -3, 2, -4, 3, -3, and 4, 0. And then when we go to sketch our parabola, look at your inequality, and because it's not equal to, we're going to have a dotted parabola. Now for the shading portion, we need to look at this inequality symbol, and it's greater than. So you find your y-intercept of the graph, and then you want everything greater, which is up. Now I'm going to shade this lightly, so we're shading inside of the parabola. Now let's go ahead and move on to our second one. Our second one, I'm going to shade it or graph it in blue. So when you put this into the calculator and get your coordinates, here are the points. So let's go ahead and plot. So we have -2, 2, and then we have -1, 5, 0, 6, 1, 5, and 2, 2. And because this has that or equal to option, this is going to be a solid line when we graph our parabola. And then again, when it comes to the shading, we have that less than symbol. So you find your y-intercept on that blue parabola, and then we want to shade down, which is again everything inside of that parabola. Now, the reason why I lightly shaded those two is because of step 2. It says we need to identify the intersection of the shaded regions. So what I'm actually going to do now is go through and just the overlap. So this section of purple is not part of the blue, and this section of blue is not part of the purple. The only overlap is here. So this is actually our solution set, just in this section. So for you guys on your paper, you can go through and erase this part. So that's why I would suggest that you guys lightly shade this region so that when you erase it, I can see clearly what your final answer is. So I want to walk through one more example. And again, if you feel like you have a good handle on it, I want you to pause, try this on your own, and then just check back with me when you're finished. Otherwise, we can walk through this again step by step. So the first thing we want to do is we want to enter the first quadratic into the calculator and use the table to find the coordinates. So these are the coordinates you should get, and then we want to plot them. So I'm going to plot using red for this one. So we have -2, 9, -1, -1, 0, -5, 1, -3, and 2, 5. So as you can see, these are not the mirrored points, and so we're just going to use those to get our sketch. Now remember, the inequality, it doesn't have the or equal to option, so this is going to be a dotted parabola. So again, it's just a sketch. Mine is a little bit off, but hopefully yours is a little closer. And then when we shade, we want to look at the symbol y is less than. So you find your y-intercept, and then you want all the y values that are smaller than that, which is in the down direction. Now the down direction is actually outside of our parabola. So we want to shade everything on the graph that is outside of our red parabola. Now let's go ahead and graph our other quadratic. So put this into the calculator, and then you're going to use your table to get the coordinates, and then we can go ahead and plot them. So we have -1, -1, 0, 5, 1, 7, 2, 5, and then 3, -1. And then when we sketch, because it has that or equal to option, this is going to be a solid line. And now we need to shade. So we have the greater, y is going to be greater than, so you find your y-intercept, and all the y values greater are above in the up direction. So again, when we shade, we're going to be shading everything outside of the parabola. Now when you're finding the intersection in the step 2, you want to be careful here. We have red and blue on this left side, red and blue on this left side. But you need to be careful because in this section, this part that's inside of the red, we only have blue. And this portion down here that's inside of the blue parabola, we only have shaded red. So you want to make sure you only shade the overlap, which is going to be over on this right side and then over on this left side. So again, this is why you shaded lightly the first time, because after you find the intersection or the overlap, you can go ahead and delete your previous shading so that now you just have your final answer. And if you want to fill it in a little better, that's perfectly fine. It's basically everything outside of the parabola, so nothing here inside of the red or inside of the blue.